solve for x. Well, there's lots of x's. And we got some relationships going on here, right? Like, here's this leg, and, well, this one's 7, I guess, units longer, and this one is 14 units longer. Let's see how this plays out. So once again, we're just going to go back to our Pythagorean theorem, and we have values to work with, so that's nice. Okay, so there's our Pythagorean theorem. We have the legs of x, and also x plus 7. So that's a binomial that we're going to have to square, by the way. Then the hypotenuse, which is going to be the leg. This looks like the shortest leg, but 14 more than it. So as I square this one, as I square the first x, not too bad, it's just squared. But as I square the second leg, which is x plus 7, I'm going to want to show this in parentheses and square it. And it will equal the hypotenuse also in parentheses, which I'm going to square also. Okay? I don't know, not really so fun, but we'll make it work. So let's take a look first at our x plus 7. So remember, x plus 7 squared is like taking x plus 7 and multiplying it by x plus 7. This does not mean that you'd have x squared plus 49. That's not what it means. You've got to square everything on the inside of that parentheses right there. So it's x plus 7 times x plus 7. So x times x is going to be x squared. X times 7 would be 7x's. And then another 7 times x is 7x's. And then we got 7 times 7, which is positive 49. Simplifying these, my 7x's right there, gives me x squared plus 14x's plus 49. Now that's just from the x plus 7 squared. Now let's look at the x plus 14 times x plus 14. Okay, so I got x times x, which is x squared. Then I got x times 14, which is 14x's. Then I got 14 times x, which is 14x's. And 14 times 14, which my calculator tells me is 196. Yeah, I forgot what it was. Yeah, sorry. And then 14x's plus 14x's is 28x's. So now I've got x squared plus 28x's plus 196. Okay, so that's just the simplification, or I guess just the expanded form of those squares. But what else did I have? Well, remember I have the other leg, which is just x squared. And then I'm going to have to add that other x squared plus 14x plus 49. And that's going to equal, now that I've got the x plus 14 squared, as the trinomial quadratic right there. But here, I still have two like terms that I can combine. I can take these x squareds. There's one x squared plus another x squared, which is 2x squared. And that just simplifies that part. So we're just left with the rest of this. I don't know. That kind of looks like garbage to me. But remember, this is now going back to what we have with factoring. Now, I'm not going to factor yet, but I know that I should, since I've got a trinomial, I want it to equal 0. And then once I factor it, then I can just set both the factors equal to 0, as long as it works out nice and pretty. So that's what we're going to do. So I'm going to make the right side equal to 0. So the first x squared, I'm going to subtract x squared from both sides. Really, it's a 1x squared. So minus a 1x squared there is going to leave me with a regular 1x squared, but we'll just make that a phantom one right there. And then the 28x's, we're going to zero that out. So minus 28x's. Minus 28x's can give us negative 14x's. And then also minus 196 from both sides. I'll go to my calculator for this one. 49 minus 196, enter, negative 147. Yeesh. Oh, okay. Well, dang it. That is going to factor. Okay, and what is this going to equal? Well, all three of our terms zeroed out, so this is what we wanted. We want it to equal 0. And since we like factoring so much, here we are again. So let's take that. It's a negative 147. Okay, it's not divisible by 2, but it is divisible by 3. How do I know it's divisible by 3? Because 1 plus 4 is 5, plus 7 is 12. And so, what the heck, 147 divided by 3. Just put in the calculator 49. Okay, well, that's not going to get me to 14, but since I see the 49, I know another factor pair is going to include 7. So 147 divided by 7 is going to give me 21. There it is. Let's see. Looks like, well, I don't see that any other factor pairs would work. But now we need this to be negative 147, so one of these has to be negative. And when we add them together, it should be negative 14. So it looks like it's going to be the negative 21. Okay, so that means if you were to take the 7 and add negative 21, you'll get the negative 14 middle coefficient right there. Now our leading coefficient is a phantom 1, so going back, this means that we can split it right now into the two binomials. We don't have to worry about factoring by grouping, but you're welcome to in case you really like it so much. And yeah, this still equals 0. Okay, but our two factors were a positive 7 and a negative 21. Now, I think some of you guys may not need the rest of the work to show this, but we're going to do it anyways. Let's see what happens with a little bit more space. So we're going to say, let's take this x plus 7, and if I could get it to equal 0, then I would get a true statement there. So minus 7 from both sides. That's going to zero out. Looks like x would be negative 7. Now, right, so we said in the last section, if you get solutions to these types of problems, make sure you check. And so we're going to eventually check. But let's look at the next one. So we're going to take that x minus 21. And if I could get this to equal 0, then it would still be a true statement. So add 21 to both sides, and we get x equals positive 21. Okay, so in checking, just in checking, okay, and I'm not even going to check up here, and the reason is because if I said this x is negative 7, I mean, that seems kind of jacked up if you said, hey, the length of this triangle, the side length of this triangle is negative 7. That's kind of weird. In addition to that, what's 7 more than negative 7? It makes this side 0. Well, that's garbage. So clearly negative 7 is not going to work. Now, if you went up here and said, well, what about negative 7? Is that going to make this work? It does. You should get a true statement up here, but again, in the context of the triangle, no good. Because that means this side length is 0. So we know that negative 7 is not going to do us any good. So let's try the 21. Let's see. If we got 21, then this side would be 21. This one would be 28. And this side length would be 35. Okay. Well, let's see if that works in our calculator. So what I'm going to do is I'm going to take the two legs of 21 and 28. Seems kind of off to me, but let's find out for sure. And if we square the two legs, add them together, then we should get the 35 as a square. So 21 squared plus 28 squared. I'm just putting this directly into my calculator. And this says the left side is 1,225. And then 35 squared, enter. It is. It's the same, 1,225. That's a 5. So this ends up showing that we have a true statement with these values. I don't know. Yeah, they shouldn't want any negative values on this, so we're just going to say this one. X is 21. Yeah, they didn't give units on that, so we'll just say, I guess, yeah, X is 21. Solve for X. That's what it said originally.